boost search relevance with click logs fast. By the end, you'll see a working Python idea that ranks documents by text overlap, then by clicks, then by a simple fusion that debiases positions. You will learn how click-through rate helps capture user preference, how to correct for position bias, and how to combine those signals with plain term matching. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. We care because click signals optimize perceived relevance, usually measured by ranking metrics like NDCG, which scores how good a ranked list is for users. The big trade-off is timeliness and bias. Click data is cheap and informative, but it carries position bias and needs memory to store logs. This technique shines on medium-sized collections where you can store impressions and clicks and still serve results in real time. It struggles when you only have tiny logs or when impressions are extremely sparse. The intuition is simple. Start with text overlap to get a baseline. Observe what users click and form a click-through rate, which is clicks divided by impressions. Adjust clicks for the fact that top positions are seen more by using position propensities. Then fuse the text score and the debiased click signal. The limit is that clicks reflect popularity and not perfect relevance, so always validate with a ranking metric. We will build 5 tiny examples on the same 3-document corpus and a 2-word query to see how clicks change the winner. This snippet scores documents by counting how many query words appear in each document, and then sorts them by that count. It stores 3 short documents and defines a 2-word query, then uses a list comprehension to count occurrences of each query word inside each document. The variable SC holds pairs of document identifier and overlap score, and a stable sort then ranks documents by score with ties broken by identifier. The printed result shows the baseline ranking if you only trust term overlap, which is a fast way to see which documents match the query textually. Now we will turn raw clicks into a simple engagement metric. This snippet converts click logs into click-through rate, or CTR, which is clicks divided by impressions to estimate how often a shown document was chosen. The snippet keeps a clicks dictionary and an impressions dictionary, then builds a new mapping of CTR values by dividing clicks by impressions and rounding for clarity. It sorts document identifiers by CTR descending while keeping a stable tie order. He output highlights which documents drew more user attention when shown. If you have few impressions, CTR is noisy and can overemphasize outliers, so consider smoothing or priors for very small counts. Next, we fuse content relevance and raw clicks to pick a winner. This snippet combines the simple text score with normalized click counts to pick the single best document. It computes a text score as the sum of counts of the 2 query words per document. Then it scales clicks by dividing by the maximum click count, so that click values live between 0 and 1. The final selection uses the index that maximizes text score plus the normalized click prior. The printed index shows which document wins when we consider both content and popularity. If you change the normalization by using a different max or a log scale, the relative influence of clicks will shift. Next, we correct clicks for position bias so popular top slots do not dominate. This snippet debiases click counts by accounting for position propensities, which are the probabilities that a user notices a result at a given slot. It maps documents to the positions they were typically shown, and then provides a propensity value for each position. By dividing clicks by the propensity for the position where the click occurred, we upweight clicks from low visibility slots and downweight clicks from the top. The dictionary W stores these inverse propensity weighted click counts. Sorting by these adjusted values reveals which documents truly earned clicks beyond positional advantage. If you change the propensity values, the debiasing strength will change accordingly. Finally, we build a tiny fused scorer that weights text and CTR explicitly. This snippet creates a blended score by adding the text match counts to a scaled CTR term and then selects the top index. It computes a simple term frequency count for the 2 query words per document and turns each document's click and impression pair into a CTR probability-like preference. The selection picks the index with the largest text count plus 1.5 times CTR. The coefficient 1.5 is an adjustable fusion weight. Increasing it makes the model favor click behavior more, while decreasing it favors text overlap. The printed index shows the final best guess under this linear fusion approach. Recap: what we built, a stepwise set of examples that move from pure text overlap to CTR ranking, to combining signals and debiasing position effects. When to use it. Apply this on medium-sized corpora with available impression and click logs to improve perceived relevance quickly. One caveat: clicks are noisy and biased, so always debias and validate before trusting heavy fusion weights. Next step, try tuning the fusion weight and measure effect with NDCG, which is a ranking metric that rewards placing more relevant items higher. Take the same code, sweep the fusion coefficient from 0 to 3, and compute NDCG on a held-out set or a small human-labeled sample. If NDCG improves as you change the weight, you have an empirical win. If not, test different debiasing propensities or add smoothing to CTR estimates. Scaling up later is straightforward. Keep the same signals, but store logs in a lightweight database and switch to an approximate nearest neighbor index for fast retrieval. If practical, hands-on IR helps. Subscribe and watch the other search and ranking videos for step-by-step guides.